Dear all, welcome back to the chapter Triangles. In this period, we will move on to our new lesson, some properties of triangles. In the previous period, we have seen the congruence SAS and ASA. Here, there are few properties related to triangles. First, let us see the parts of a triangle once again. In a triangle, for example, here it is DCE. Angle C, angle D, and angle E. These are the three angles in the triangle, which are represented by just one letter, angle C, angle D, and angle E. How do we represent a side? A side can be represented either by two letters, for example, side CD. Even you can write it as with a line segment, or side DE, or side CE. These are the three sides of the triangle here. In a shorter way, we can also represent the side in a different way. At this vertex, the angle is D, and the side opposite to D is represented by small letter d. So this is another way of representing the sides of a triangle. How? One small letter. And which letter are we using? The letter which is opposite to that side, or the angle which is opposite to that side will represent the side. For example, here it is CE is represented by the letter D, small letter, but one letter only. DE is opposite to the angle C, so it will be letter C, and the side CD, which is opposite to angle E, so this will be letter E. These are the representations of the side using small letters. We have seen the types of angles based on angles and based on sides. Based on angles, we have acute triangle, right triangle, and obtuse triangle. We have seen about it before. Now we need to go in detail about the types of triangles based on sides. Here they are. If all the three sides are equal, we call it equilateral triangle. Here we have three equal sides and three equal angles. And we have seen that all of the angles will be equal to 60 degrees if it is an equilateral triangle. Doesn't matter how small or big it is, each angle will be 60 degrees. The second type of angle is called isosceles triangle, and there was a tricky term to understand eyes. It is a rhyming word with eyes. We have two eyes, so if two sides are equal, this is called an isosceles triangle, which will have two equal sides and two equal angles. And the last one from here is scalene triangle, which means no equal sides, so we will not have any equal angles as well. Each one will be different from the other. So these are the classification. Especially, we need isosceles triangle, which means two equal sides and two equal angles. Based on this, we have a theorem in this lesson. The theorem says angles opposite to equal sides of an isosceles triangle. You know, isosceles triangle means it will have two equal sides. The angles opposite to it, to the side CA, B is the opposite side. B is the opposite angle. And to the side CB, A is the opposite angle. So they say that if you have a triangle isosceles, then the angles which are opposite to equal sides are equal. Let us see how to prove this one. For that, we need a construction. Let us construct a line from C to D in a way that angle ACD, the angle which is formed here, is equal to the angle which is formed here. Or we can say CD bisect angle C. So that is a construction, and we already have side CA is equal to AB. So let us see in the triangles CDA and triangle CDB, we can see that CA is equal to CB because the triangle is isosceles. And now by construction, we have angle ACD is congruent to or equal to BCD by construction. Okay. Now CD is common to the gray triangle and to the white triangle. So we can say CD is common. So here we have a side, an angle, and a side. So we have side, angle, side. By SAS, triangle ACD is congruent to triangle BCD. So we can see that the angle which are in the beginning, see that letter A is in the beginning, letter B is also in the beginning. Angle A is congruent or equal to angle B. Why? Because corresponding parts of congruent triangles are equal. The angle which is the first letter of the first triangle will be equal to the first letter of the second triangle. That is the corresponding parts, and they are equal. So we proved that if two sides are equal, then the opposite angles are equal. Let us see the next theorem, which is just the opposite of it. If we have two angles equal, which means this angle is equal to this angle, then we can show that these two sides are equal. This we have to show. Again, let us go through the construction. Let CD bisect the angle C, which means these two angles are equal. And we are already given that these two angles are equal. So let us consider the triangle CDA and CDB. In those two triangles, we have ACD. Angle ACD is congruent to angle BCD. They are equal by construction. And we are already given angle A is equal to angle B. And side CD is common for the green triangle and for the purple triangle. So CD is common. So now we have angle, angle, side. Here is the angle, 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 side. So by AAS congruence, we can show that triangle ACD is congruent to triangle BCD. These two triangles are congruent. Now we have to think about the side AC and BC. Look at this one, AC and BC. They are the first two letters from both the triangles. So we can say AC is equal to BC, CPCD. Corresponding parts of congruent triangles are equal. So what did we get now? Two sides are equal. So if two angles are equal, then the opposite sides are equal. Let us see more examples. In triangle ABC, the bisector AD of angle A. Bisector of angle A, which means these two angles are equal, is perpendicular to BC. Perpendicular means it is 90 degrees. So we already got all the conditions. Look at this one. We have an angle, we have a side, we have an angle. So by ASA, these two triangles are congruent. So let us take the triangle ADB and ADC. So in triangle ADB and triangle ADC, BAD, angle BAD is congruent to angle CAD. Because angle A is bisected, or AD is a bisector. Now we have AD is common. AD is a side for the yellow triangle and for the brown triangle. So we have an angle, a side, and we have both of them are 90 degree. So angle ADB is equal to angle ADC is equal to 90 degree because they are perpendicular. So by ASA congruence, triangle ADB is congruent to triangle ADC. Now the question is to prove AB is equal to AC. AB is the first and the last letter. AC is also first and last letter. So AB is equal to AC because corresponding parts of congruent triangles are equal. So if two sides of a triangle is equal, then we say that the triangle ABC is isosceles. Okay, let's move on to another example. E and F are the midpoints of equal sides of AB and AC. First of all, these two sides are equal. The whole AB and AC are equal. And E and F are the midpoints, which means these two parts are equal. So finally, all parts will be equal because if this whole AB is 10, each one will be 5. AC is also 10, so each one will be 5. So all of these parts are equal. Now we have to show that BF is equal to CE. BF is a part here and CE is a part inside. So for that, we have to consider the inner triangles AFB and AEC. From these two triangles, what can we say? From triangle AFB and triangle AEC, we can see that AB is equal to AC because it's given, two equal sides, it's given. Angle A is common because angle A is for the brown triangle and for the blue triangle, so it's common. So we have one side, one angle, and again you can see that AF is a side of the brown triangle. AF is equal to AE is the side of blue triangle. They are equal because if the full sides are equal, their halves are also equal because E and F are the midpoints. Because E and F are midpoints. So we have the third side. So we have SAS. By SAS congruence, triangle AFB is congruent to triangle AEC. So if these two triangles are congruent, we can prove that BF and CE. BF is the last two letters, CE is also the last two letters. So BF is equal to CE because they are corresponding parts of congruent triangles. We'll move on to the new example. In an isosceles triangle ABC, AB is equal to AC. These two sides are equal. We have studied that if two sides are equal, then the opposite angles are equal. So angle B is also equal to angle C. Now the question continues, AB is equal to AC and BE is equal to CD. BE equal to CD means the base of a triangle with BE and another triangle with base CD. So let us consider the two triangles ABE and ACD. So from the triangles ABE and triangle ACD, CD, we know that AB is equal to AC because it's given isosceles triangle. We have one side now. Angle B is equal to angle C because they are isosceles. Angle B equal to angle C because isosceles. So we have an angle now. Side BE is equal to side DC. It's given. So now we have by SAS triangle ABE is congruent to triangle ACD. Now the question is to prove that AD is equal to AE. AD is the first and last letter. AE is also first and last letter. So AE is equal to AD because corresponding parts of congruent triangles are equal. Isn't it easy? We are just applying the rule of isosceles triangles. So we come across the rule that in an isosceles triangle, if two sides are equal, the opposite angles are equal. That's all for this period. Thanks for watching. Take care and see you in the next period. Bye for now.